Welcome to AP Physics Part 2. Before we get started with instruction, let's talk a little bit about this class and a little bit about physics as a field. What do you suppose these three phenomena have in common? The orbit of the moon around the Earth, an apple falling from the tree down to the ground, and the shape and motion of distant galaxies, or our own Milky Way. You might be able to remember from Part 1 that gravity is the universal force that explains all of those things. How about this? What do these three things have in common? A car battery, a fastball, and about 1 billion gallons of water way up high behind a dam. Again, if you remember Part 1, you might recall that all of those things contain energy. How about this? Can you think of a college major that could lead to a career studying the stars as an astronomer, working as an engineer to design bridges, writing software, maybe for the game industry, but maybe for NASA, and working as an oceanographer to study waves and ocean currents? If you've been paying attention and you signed up for the right class, you can probably guess that that major is physics. So what is physics? Hoping here you have not forgotten over the summer. Physics is what Isaac Newton called the system of the world. It's how everything works. You can think of it as like the operating system for reality. It's what's happening under the hood and behind the curtain. Formally, it's the study of matter, forces, and how they interact, and it is a really big subject. Particle physics, theoretical physics, high-energy physics, condensed matter physics. If we're honest, chemistry is really just a specialization of condensed matter physics. Astrophysics, as your space science, thermodynamics, relativistic mechanics, and lots more. So much that physics, even at the high school level, the AP level, is split up into 2 courses. So what is AP Physics? The equivalent of a college-level algebra-based physics course. We still don't really get into calculus here in Part 2, although we occasionally show you some calculus equations just to scare you with them. Part of a 2-course series, of course. You've already taken AP Physics Part 1. That was mechanics, forces, interactions, motion, and a little basic electrostatics, which we didn't really get to that time. AP Part 2 will be electricity and magnetism, thermodynamics, fluids, and nuclear physics. It is excellent college prep, and preparing for college is still the real goal. Not trying to get out of college classes with a test, but we're still going to sign up and take the AP test anyway, right? Right, because taking the test, planning on taking the test, studying for it, and working towards it all year is an important part of college prep. Who am I? Hopefully you remember me. I'm David Stroop. Got a Bachelor of Science in Physics from the University of Hawaii and a Master's in Secondary Education. I've had a long, weird work history, depending on how you count it. This is about my 4th career. I was a reporter in newspaper and radio, a newspaper editor, worked in marketing in the construction industry, freelance writing, editing, and cartooning. I've published a couple of novels. I'm married, I have 2 kids, and I live down in Oregon City. So what are we going to study this year? Well, not exactly in this order. We can talk about that when we're in class. But our units include electrostatics. That's basically charge and how charged objects interact with each other. But we will build on what normally would have been the Part 1 version of this with the concepts like the electric field and electric potential. Electric currents, that's Ohm's law, which is day 1 stuff for a career as an electrical engineer. Magnetism and electromagnetic induction. That's the relationship between electricity and magnetism. Electric fields and magnetic fields are really just 2 different versions of the same thing, seen from different reference frames. And in college, you would learn some calculus equations, Maxwell's equations, to explain how those things interrelate. Thermodynamics. That's kinetic energy, ideal gases, entropy, how engines work. Fluids, density, pressure, buoyancy, Archimedes' principle. Things are supported by the weight of the water that they displace. You might remember Archimedes is that guy in the bathtub. Geometric and physical optics, in other words, image formation, how lenses and mirrors work. And finally, quantum physics, atomic and nuclear physics, a little bit of relativity, photoelectric effect, mass energy equivalence, and radioactive decay. And if we are able to get back together, we can do our cloud chamber lab. The cloud chamber is actually something that you can learn about online, and I may be able to assign that as an optional home project for you to do on your own. So what are we going to study? All right. In AP Physics, these subjects are divided up based on a series of what they call big ideas. And we'll learn more about these as they go along, but hopefully some of these concepts will be familiar to you from Part 1. Big Idea 1, objects and systems have properties, like mass and charge. Fields in space can be used to explain interactions, for example, a gravity field. Interactions of an object with another object can be described by forces. That was our Newton unit, pulling and pushing on each other. Interactions between systems can result in changes in those systems. Changes that occur as a result of interactions are constrained by conservation laws. Remember, conservation of momentum and conservation of energy. Waves can transfer energy and momentum from one location to another. And the big idea for Part 2, the mathematics of probability can be used to describe the behavior of complex systems and to interpret the behavior of quantum mechanical systems. So part of that is thermodynamics, the ideal gas law, and the concept of entropy. There are also 7 big science practices, which we want to use when we are able to do labs. Number 1, using representations and models to communicate scientific phenomena. Using mathematics appropriately, engaging in scientific questioning to extend your thinking, planning and implementing data collection strategies, performing data analysis, working with scientific explanations, and then connecting and relating that knowledge across various scales. Would you like to know more about what we're going to cover? Of course you would. So one of the first things for you to do is to get the syllabus. That's going to be available all year off of the Canvas site. It'll be a sort of a living document. In other words, I'm going to update it as we go along and the situation changes. You might recall this. Here are some of the most important things off of the syllabus. So first of all, your textbook is still College Physics for AP courses. If you no longer have a PDF copy of that, go and download another one or be prepared to access it online. We are going to continue to use it more, especially with distance learning. There is also a new high school physics textbook that I'm going to make available to you, which is kind of an AP Physics light kind of thing. If you find the main one a little bit overwhelming, you can have a look at some of the relevant chapters in high school physics. You're still going to need a scientific calculator, a composition book. You can keep on using the one from last year as your lab book. Some way of taking notes and keeping them separate from your lab book. A 3-ring binder with dividers. This is something we tell you every year, that you might need to show this to your college. It's still possible, so you should be keeping your handouts, homework, return projects, and so on. And somewhere locked away at school, we've got our classroom set of Physics by Giancoli. The goal is to have the grading break down about the way it did when we were in person. So tests about 45%, lab papers and projects 45%. Those will probably not be the really big papers that we did last year, not with only one semester. Bi-weekly quizzes, pop quizzes, and all of that stuff is still about 10% only. The equations sheet is still your best friend, so you have a slightly expanded one. This larger block here is your important constants, like strength of gravity, but a lot of new stuff also related to electricity and magnetism. Units and symbols, kilograms, meters, and then a table that reminds you that kilo in kilograms means times 1,000, centi in centimeters is 1/100th. Basic trig, basic assumptions, things like ignore friction unless I say otherwise. It's 3 pages now. So on the second page, you've got all of your mechanics equations from last year, and then also electricity and magnetism. At least as many equations as mechanics. So there are going to be a lot of equations to use there. On the third page, you've got fluid mechanics and thermodynamics, modern physics. Notice that E equals mc squared is down there. Waves and optics, last year that was basically one equation. The first one there, the related wave speed, velocity with wavelength and frequency. Now you got a lot more. A bunch of that stuff is has to do with how lenses form images. And then you've got your block of geometry and trig still, which you hopefully remember from last year. Same stuff, you still got that triangle there to remind you about opposite over adjacent and Pythagorean theorem and all that good stuff. The AP test, so right now it's scheduled for 2 weeks in May. Part 1, May 5th. Part 2, May 7th at noon. Now, we don't know what's going to happen. but right now it is scheduled as a live in-person test. You might recall that last year the test was sort of abbreviated. This year the College Board, with a full year to prepare for it, with a possibility it will be at home again, has said that it will be the full AP test with all of the material that would normally be on the AP test, whether that's at home or in person. So, a reminder, Part 1, multiple choice, 90 minutes, 50 questions, 4 possible responses for each. Guess if you have to, no penalty for guessing. The last several, probably the last 5, will be pick 2. You didn't see this last year, but it's like the way that multiple choice questions are set up on my tests. Page 2, or Part 2, is still free response. 4 of those for AP Physics. Part 2, no one knows why, only 4. Each is broken down into multiple parts. Don't leave any blanks. Remember that if you can't handle Part B, go on and try Part C. You can even say, okay, assume the answer to A was 19. Now for B, do this. All of that is still true, except you get 4 questions on free response instead of 5. Note taking is going to be important. You got your PDF textbook, but you're going to be given everything you need in your notes. So that's like your real textbook. 2-column notes are nice, but really you can follow your own style. There is scientific evidence that writing it down, like really writing it down, not just with a keyboard, helps you to learn. So taking the class, here are the first steps you need to do. Get the syllabus. The latest version should be available from the website, on Canvas website. Get the textbook if you don't already have it, and check out the other resources on the textbooks page on Canvas. Read and understand the safety form, which is part of the syllabus. Sign it. Have a parent or guardian sign it. Now, you still got to turn that in to me, so you're going to submit it by taking a photo of the signed last page and submitting it online as an assignment, and do the same thing with Contract for Physics with Mr. Stroop. That's the one that says that you understand about academic honesty and the stuff that you need to get for the class. You should also, very soon, log on to your College Board account, sign up for this class with the join code you'll get. This is like how we did it last year, and we will talk about it in class when I've got the join code for everyone. You can and should sign up for the AP test at the same time. Remember that payment will be handled later. The school's been very good about making sure everyone can take the test. You got to be signed up for the class in the AP College Board system for some of the things we do. In other words, we're going to try their personal progress checks again. I know that there were a lot of problems with those and the online version of the test last year, but we're going to give it a shot, and there is no sign for this stuff. Paying for the test is totally separate from all of this. All right, that's it. Start on those steps, get the syllabus, take care of those forms. Because we kind of know each other already, and you've got a running start from Part 1, we are going to jump straight in with our first unit and not have an introductory unit about measurements and unit conversions. So I will see you soon.